We've looked at situations where you have no solution or where there are infinite solutions. And there's a third situation that isn't really weird like those other two, but sometimes it feels like it's weird in that way. It's actually more of a normal situation where you're just getting a single solution and your answer happens to be that the number is zero. But it's worth looking at because of some similarities it has to those situations, and more because when you see it, sometimes you feel like, oh, I guess I have no solution or infinite solutions, and it's worth meeting it head on. So let's say you have an equation like this. 6 times 1 minus 2x equals minus 2x plus 6. You might look at it, might feel like, oh, well, I see, looks maybe, I don't know, I got the same coefficient for x on both sides like that, and then looks like I've got the same, well, there's a 6 as well. Is this going to be infinite solutions here? Well, we'll see. It doesn't actually work out that way. If it's always a good idea to follow these equations through using the usual techniques for solving an equation. So you go ahead and you say, all right, let me first simplify the left-hand side here. I'm going to distribute the 6 into the brackets. 6 times 1 gives me 6. 6 times minus 2x gives me minus 12x. And then your next priority's got to be, okay, well, I want to get the x's together on the same side. So you could either add 12x to both sides or add 2x to both sides. Here, I'm just going to add 2x to both sides. That way, I'll have no x's over here on the right. And when I do that, I get 6 minus 10x, because minus 12x plus 2x gives me minus 10x. And these guys are knocked out. All I've got left over here on the right is 6. So now that I've got all the x's on one side, now it just becomes, okay, I want to isolate x. So to get x alone here, first, well, let me get rid of this. So I'm going to subtract 6 from both sides. I've got minus 10x equals 0. Now to get x alone, a lot of people freeze up at this point. They feel like things have gone wrong. No, you just follow the same rules. 0 is a perfectly good number. There's nothing wrong with 0. Let's isolate x by dividing both sides by minus 10, right? Because that'll give you just x on the left-hand side. So now I have x equals 0. And that feels weird, but it's fine. There's no need to panic. If you're saying to yourself, look, this doesn't seem right, then remember, you can always just plug that number back into your equation and see if it works, right? So this was our original equation. Let's replace x with our value so we can verify. So let's replace all the x's with zeros. And now just do some bad math to see if this works out, right? So, all right, now over here, let me see. First thing I would do is minus 2 times 0. Which would give me 0. And then over on the right side, I'd do minus 2 times 0 as well, which would also give me 0. Now over here, I would do 1 minus 0, which is 1. And 0 plus 6 is 6. So now I've got 6 times 1, which is plain old 6. 6 does equal 6. Yeah. So when I plug this number in, 0, I'm getting that it works. This seems to be fine. X equals 0 is correct. Let's try another example. This one is one that you should fill in. If you go to page 15 in your unit book, one of the examples that you do need to show is completed when you're handing in your book. Go to page 15, see this example here. We got 15x plus 11 equals 3x plus 11. Again, your spidey senses might be telling you, okay, well, maybe this is, I don't know, infinite solutions or something. Let's just use regular principles of solving equations to see where it takes us. Okay. Got to get the x's together. Let's subtract 3x from both sides to do that. That gives me 12x plus 11 on the left and just plain old 11 on the right because these guys knock each other out. Now I want to get the x all alone, so I'm going to subtract 11 from both sides. I have 12x equals 0. I'm going to divide both sides by 12. 0 divided by 12 is 0. 12x divided by 12 is x. So I'm getting x equals 0. Again, if you plug that back in, 15 times 0 is 0. 0 plus 11 is 11. 3 times 0 is 0. 0 plus 11 is 11. I'm getting 11 on both sides. It works. So let's look at this equation here that we had in that example. It was 15x plus 11 equals 3x plus 11. If you look at that equation, what do you notice? I've got the same constants on both sides here, 11 and 11. 15x and 3x, that's different coefficients. So when you have an equation with different coefficients on both sides and the same constants on both sides, then you'll have x equals 0. Now you might be saying, well, isn't that what we already saw for some of the other ones? No, it's similar but different. With infinite solutions, you need to have the same coefficients on both sides and the same constants, right? For no solution, you needed to have the same coefficients on both sides but different constants. This one is different coefficients but the same constants. And if you have different coefficients and different constants, that's just a regular equation. Okay, so let's see if knowing that, if we can try and write some equations that have the solution x equals 0. We know we got to have different coefficients. So, I don't know, it's 3x and 19,876x. Those are pretty different, right? And then I just got to add the same constant to both sides, right? So let's just say I'm going to make it 3x plus 5 is equal to 19,876x plus 5. So I've got different coefficients. The 3 is very different from the 19,876. But the 5 and the 5, the constants, are the same on both sides. If you have an equation like that, your answer will end up being that x is 0. Another example, I could do 14x minus 2 is equal to minus 14x minus 2. You might look at this and think like, oh, this shouldn't that be infinite solutions? No, 14x is a very different coefficient from minus 14, right? They may look the same, but they're actually very, very different. This is x equals 0. You could also have this, right? In this case, the constant that I'm adding to both sides is just 0. I'm not adding any constant at all. So if I just have different coefficients for x and I make them equal to each other, this equation is true if x is 0. Right? Think of it. 3 times 0 is 0. 300 times 0 is 0. 0 equals 0. Yeah, that works. X equals 0 works in this equation. So it's important you understand one thing. When you get an equation for x equals 0, that is very, very, very different from an equation where you have no solution, right? Where you write x equals sideways mustache, O with a line through it, sideways mustache. You have no solution, very, very different from x equals 0. When you have x equals 0, that means, yeah, there is a solution. I solved the equation, and I've got an answer that works. That answer is 0. If I plug 0 in, it will work. It'll make the equation true. But if you go through and you solve it and you get like 5 equals 7 or 2 equals 9 or something, and you write no solution, what you're saying is it's impossible to solve that equation. And there's no number that you could plug into it that will make it work, including 0. Plugging 0 will not make it work. So x equals 0 makes sense if plugging 0 in works, and no solution means there's no number that I could possibly put into this equation that would make it work. So a little recap from what we've seen yesterday and today, and that is that an equation can end up, if you do follow solving the principles of an equation, end up with something like 5 equals 12, right? Like let's say an example of this would be x plus 5 equals x plus 12. You subtract x from both sides, you get 5 equals 12. That means that there is no solution. And remember, if you see something like 5 equals 12, you can say like, oh, that's a lie. That's definitely not right, right? So that's not a solution. You get something like that, you say, boo, x has no solution here. X equals sideways mustache, O with a line through it, sideways mustache. Now, this will happen in equations where you've got the same coefficients and different constants. Like I said, if you had something like 2x plus 5 equals 2x plus 12, or 2x plus 3 equals 2x plus 4. See, I've got the same coefficients here. They're going to cancel each other out, and that all that's going to be left are these different constants, 3 and 4, looking at each other and saying that they're the same as each other, and you know that 3 is not equal to 4. You learned that a long time ago. So when you see a hideous lie like that, that means there's no solution. If you see something and after you solve it, you end up with 0 equals 0, then you can think in your head like, oh, I can picture a little smiley face on this guy. Those are his eyes, right? That's a good thing. You could say that an equation like this is always true, that there are infinite solutions. Anything you plug in there works. It's so happy to welcome anybody as a solution. And you could say that that has infinite solutions, or that it's an identity. And that will happen in equations where you have the same coefficients on both sides and the same constants on both sides. Like, for example, 2x plus 3 equals 2x plus 3. I got the same coefficient on both sides, 2x, 2x, and the same constant, 3 and 3. And look, the two sides here are identical. That's why you can think of it as an identity. You plug in any number for x here, and it'll work. The last one, the one we just saw today, if you work an equation, you end up with x equals 0. This may feel weird, but it's just a regular equation that has one solution that happens to be the number 0. So you just say, all right, my answer is x equals 0. And it'll happen in equations where you have different coefficients, but the same constants. For example, 12x plus 3 and 2x plus 3. 12 and 2 are different coefficients here. 3 and 3 are the same constants. So in this case here, the only answer that'll work is 0. It's not that you have no solution. It's that x